Hi, welcome to Pi Planet, and we've got another question for circles. Here we are. We are sharing my screen. Yes, uh, question which we have, and it says that there are two circles, and they are both are intersecting each other at point B and C, and BC is the common chord. A and D are the 2 points on the other segments of the circles. So let's start, putting this question onto this figure. And the first thing is that there are 2 points where these two circles are intersecting. So let's have these 2 points drawn here. So suppose this is B and say this is C. So I'll put the names also. So this is B and C. And BC is a common chord for both the circles. This is what we understand, right? This is what is given in the question. And it also says that, A and D are 2 points on the other segments of the circle. So suppose A will be on this side because we are talking about other segments, and D will be on this side of the circle, such that ACD is a straight line while going through the center P. So this is, suppose, the center, right? And this line is going through from C and then intersecting this circle at, say, D, right? So I'll just name this, yeah, this is D, and I'll remove this so that there is no confusion. And this is further extended, and this point is A, right? So this is how it is, and they are saying APB is 130 degrees. So let's also connect A with B, and this angle is 130 degree. This is what is given. PQ are the centers of the circle, and we need to find B angle BQD. So if this is the center of the circle, let's also connect B with Q, and we connect this also, right? So what we need to find out is this angle. This is what we need to find out. All right. So now let's quickly start, solving this question. And first thing is that because our line APCD is a straight line, APCD is a straight line. I can always say that this angle is going to be 50 degree, right? Because this is straight line, and this 50 degree, this angle is 180 degree minus 130 degree. So we can say that, angle BPC is equal to 50 degree, right? Now, we also understand that PC is equal to PB. So we can write PC is equal to PB, and that's because they both are the radii of the same circle, right? So which basically means that our triangle PBC is an isosceles triangle. And in any isosceles triangle, the opposite angles, the opposite angles of the equal sides, that means these two angles, are always equal to each other, right? Now, in this triangle, we can always say that angle BPC plus angle PCB plus angle PBC will always be equal to 180 degree, because that's the theorem of sum of all the angles of the triangle. So this is how we can write, and angle BPC can be written as 50 degree, because we just found that out. And Now we have already proven that these two angles are equal to each other. These two angles are equal to each other. So what we can write is very simple. We can simply write, you know, that double of angle PCB, right, is equal to 180 degree. And therefore, I can find out angle PCB very easily, and that's like 130 degree over 2, and that's 65 degree. So our this angle is 65 degree. Now, since APCD is again a straight line, we can always, mention that this angle is 115 degree, right? Now, we will just make a point here and say that is X. And now let's connect D with X, okay? And then I'm connecting B with X. So if we clearly observe, we will see that BCDX, BCDX, that's a cyclic quadrilateral, right? So that's a cyclic quadrilateral. Now, in cyclic quadrilateral, we already know that the sum of the opposite angles is always equal to 180 degrees. So I can write angle BCD plus angle BXD will be 180 degree, which means that we can find out the angle BXD is equal to 180 degree, and this angle being, we just found it out, that's 115 degree, this one, right? We just found that out, so we can always write minus 115 degree. So that's equal to 65 degree. So that means this angle is 65 degree. And we also know that any angle, if that angle is subtended by the chord, so suppose BD is a chord, right? That means this angle is basically subtended by the chord BD on the segment of a circle, on the larger segment of the circle. So that means the angle which will be subtended by this chord BD at the center will be the double of this angle. That's the theorem which we have already understood. So we can write that, with the help of the theorems and chords theorem, with the help of the chords theorem, we always write that the angle BXD will be half of angle B, and that's Q. I'm so sorry, we are marking it now. So that's angle BQD. Yeah, so angle BQD. And we need to find out angle BQD here. So here we can simply find out the value of angle BQD, and that's 2 angle BXD, which is equal to twice the angle 65 degree, and that's the 130 degree, right? So that's the answer, and I hope you guys enjoyed doing it and also understood. Keep watching these videos. We'll be coming up very soon with the statistics videos also for grade 10 board IGCSE, ICSE and CBSE. I hope you guys enjoyed it. Thank you so much. Have a nice day and bye bye.